Thank you for coming back for lesson number part 3 in our series on lecture number 25. Line integral by Dr. Emanuel. This example here is we want to find the work. The work is defined by the force times the integral of the force times dr for f equals x squared plus y squared I minus 2xy j plus xk. This time we have a k in it and a z. Okay, so let's see how that changes. Along the portion of the circle. Okay, so we're looking at a portion of a circle. We're not looking at 360 degrees. We're not looking at 2 pi. We're only looking at this curve. That's it. Just this portion. So I drew it here for us. So you can see this is A, the x-axis, and this is on the other side, the negative axis, on the x-axis. Okay, and we want this to go from point A, 0, 3 to minus A, 0, 3. So what we have, we know that x is equal to a cosine theta, dx is equal to a negative a sine theta, d theta. We have y is equal to a sine of theta, dy is equal to a cosine theta, d theta. Z equals 3, and the derivative of 3 is 0. So now we're looking at this work, f times dr, and we find out that, okay, that this is x, this is just basically dx, x squared plus y squared, that quantity times dx, and minus 2xy dy, and this just has the dy, and the z is x dz. So we're going to substitute for x squared, as we mentioned up here, a squared cosine squared plus a squared sine squared. This is our y squared. Dx is equal to minus a sine theta dx minus our 2, and then x is a cosine theta, our y is a sine theta, d theta. Okay, so we have this portion, and we have now our dy is a cosine d theta, which is here. And then we have our z, which is our x again, a cosine theta times dz, which is 0, so this goes out. So what do we have left? We have an a squared all the way across. We can pull that out. And so now what we have here, you have a squared pulled out. And if you look back here, you have another, I think it's another a squared. Okay, we pull this together. Cosine squared plus sine squared, we pull an a squared out, is equal to what? 1. Okay? So this is just a squared. That's the identity. So now we have here a minus a sine of theta d theta minus 2. We have a cosine of theta times a sine of theta then a cosine of theta, so that gives us a cosine of theta squared d theta. And then we can pull out a cubed. This is an a cubed. This is a cubed. So then all we're left with is a minus sine theta d theta minus 2 sine of theta and times the cosine of theta squared d theta. So this is what we had from the last page that we're carrying over for our work, for our DW. Okay, now for us to find the work, we need to integrate this dW. And if we integrate this dW, we're going from 0 to pi. And so the first thing we could do is pull out a -1, -1. We can pull those out. We already pulled out the a cubed. Okay, so now we have sine theta d theta plus 2 sine theta cosine squared theta d theta. Then we have a -1, which we said we pulled out the the a cubed, we're pulling out 0 to pi. We have sine of theta d theta plus sine of theta times the cosine square of theta d theta. Using u substitution, we would like to substitute for here cosine of u, and the cosine, the derivative of cosine is minus sine d theta. That's what we're going to replace here. So we see our work here is we're going to still pull out the 1 minus our constant out front. Then we have our sine of theta d theta plus 2 the sine of theta cosine of theta. Pull out this constant. And we have here, we're going to evaluate this. Cosine from 0 to pi, we have 2, that constant. And here we replace this with u du. Here we have that constant again. And now we plug in cosine of pi, we plug in the cosine of 0. Here we have a negative, we bring that negative out, that 2. And now we have what? 1/3 u cubed. And so next we have the constant again, and then we have the cosine of pi, it's a -1. Remember, there's a negative all the way out front. There's a negative all the way out front for this. Okay, so that's 2 cosines, 2 of them, and the cosine of a -1. We have a minus a 2 to the 1/3, but this is what the cosine cubed theta from 0 to pi. So what we have here under work, stay like constant, we have all of these negative signs with the 1s. We have here the 2, and we're going to be evaluating cosine cubed at pi pi, and 0. This here, constant, and this comes out to be 2. And then we have here this 2/3 times these quantities here. So if we have for pi, cosine is at -1, but it's cubed. And the sine and the cosine of 0. And since you're subtracting it, it's a -1. So you got that cubed. And so you have a -2 that you're pulling out. And this is that constant we were talking about earlier. And now this quantity here, you have as 4. 1, 2, 2, 4 over 3. So you have your 4 over 3. You have your -2 out here. And when you add these together, I get a -10, 3a cubed. So all negative. So our work here is -10 over 3a cubed. Now, the rule is that if the line integral is path independent, then the force is conservative. So when you're talking about the path is independent, that means it can go anywhere you want, any way to get to that path. So that's why it's independent. Otherwise, non-conservative. Recall last lecture, under field is conservative if what? If the curl of the function equals 0. If the field is conservative, okay, that means it has what? Many paths. Paths are independent of each other. You can pick a different path. You can pick whatever path you want. Okay? Now, notice here, we have 2 paths. We see W1 is greater than W2 because of friction. This is here dealing with friction. And up here, you're not dealing with what? Friction. Okay, we will take another break and come back to part 4.